Hi, everyone. How do you graph y equals x to the negative 2? How can you rewrite x to the negative 2? It's 1 over x squared. Now, if f of x is x to the negative 2, consider f of opposite of x. What happens if you replace x with its opposite? Well, the square doesn't care about the negative 1 factor in here. We just end up with 1 over x squared, or f of x itself. That's true all throughout the domain, which is going to be this over here, all reals except for 0. Same domain here. Symmetric about 0. What kind of function is this? It is even, which means that the graph is symmetric about the y-axis. Y equals x squared, we know, is symmetric about the y-axis. What about this guy? Now here's y equals 1 over x. This was odd, remember? Symmetric about the origin, 0, 0. But now, what about y equals 1 over x squared? How would that graph be different? Yeah, in quadrant 1, it'll look a bit different. But how will this graph be different? It's going to be in quadrants 1 and what? Not 3. Quadrant 2. If you said quadrant 4, be careful because you probably don't have a function then. If you have a quadrant 4 piece, right? Okay, y equals 1 over x squared. Let's choose a better color. How about blue? There we go. In blue, all right? Y equals 1 over x squared. I call this a volcano graph. Quadrants 1 and 2. So the piece in quadrant 1 looks kind of similar to the piece for the green graph, y equals 1 over x. But the key difference is, okay, for the volcano, the other piece is in quadrant 2, not quadrant 3. We have an even function, not an odd function. We have symmetry now about the y-axis. Right. You can do some point plotting, but that's the basic idea. Okay, here's y equals 1 over x squared. And then for other guys, y equals 1 over x to the fourth, or 1 over x to the sixth. That is x to the negative 4, x to the negative 6, and so forth. All right, you'll have similar graphs, quadrants 1 and 2. So if I have y equals 1 over x to the fourth, y equals 1 over x to the sixth. All right, flatter out here, steeper in here. All right, similar. All right, at this point, you should be able. Oh, and by the way, we have the same we have the same asymptotes. The x-axis is an HA, the y-axis is still a VA. Now, at this point, you should be able to graph anything of the form y equals x to an integer. Next, what about y equals x to some other rational exponents?